Testing, testing. Testing. Testing, testing. Testing, testing. Welcome back. Today, let's play some Human Resource Machine. And let's see, there we have the cat. So, yes, please select your employee ID. Yeah, that's what I'm gonna do. So, last time we got up to, well, about the end, but we missed the free sort. So let's have a look at that and see what we can do about that. Not saying that this will be good, but let's see. The thing is, we got it sorted, but we didn't optimize it in any way. So let's try to optimize something now. But what? Let's see, what is the exact topic we want to do? Yeah, that's not what I... Oh, it says over here. For each 3 things in the inbox, send them to the outbox in order from smallest to largest. Okay, let's try to do it in as few steps as possible. So, we go from inbox, we have one number. Let's copy that to number 2. So this number 2 is actually the first number, which is A. And then let's go to the inbox, grab the next number. What do we want to do with the next number? Well, we want to see if that's lower or higher than A. How do we do that? Well... yeah, how do we do that? If we subtract A, so in this case 4 minus 8 4 minus 8. So if this is negative, actually no. Since we are after the fewest steps, let's always copy it to over there first. And this is always number B, which is the second number. Doesn't matter if it's higher or lower right now, it's always that. So subtract A if if B minus A in this case will give negative number. So if it is negative, we go here, and that means okay, that means B is smaller than A. We are not handling the same numbers. And if it's not negative, it means that B it's larger than A. I'm basically building up the same thing we have already, but hopefully with fewer steps. That's all we need to do for the second number. We have stored it, we have gotten A, we have stored it, we have gotten B, we have stored it, we have checked which one is smaller or larger. So now we want to grab the last number. And we do that from the, grab it from the inbox. We grab it from the inbox. We copy it to C, which is the phone number. We know that B is larger than A. Does it matter if we check it against A or B? And my answer is no. So we have C. Let's subtract A just to have some number, and then we can do another if negative. So we know in this case, oh no, let's get rid of that. In this case, it's the same as that case, so C is smaller than A. No, C is C is larger than A. Okay, and then we know in which order we should get all of the numbers out. Okay. So do we? B is larger, C is larger? No, we don't. Because in this case, we don't know if B or C is larger. So we have to do another check. But in this case, in the other case where it is negative, then we know that C is smaller than A, I think. And since B is larger than A and C is smaller than A, we can just output things. So copy from C, the outbox, copy from, that's smaller, that's the largest, copy from A and go to the outbox, and copy from B and go to the outbox. That should work out. But in this case, if it's negative, we need to figure out is where C is. Is it larger or smaller than B? In this case, actually, no, maybe. If we don't do that, we grab the inbox, we grab the C, we subtract A, and if it's negative, we know that C is smaller than A, then we add A again to get back the same number. That saves us from first storing it and then reading it. So we add that, then we go to the outbox, do A to the outbox and B to the outbox. In this case, in this case, we know that C is larger than A. Actually, I should change all of these to have always have the smaller one on the left. So in this case, A is smaller than B. A is smaller than B. That makes it easier to see what's happening. A is smaller than C. A is smaller than C. And in this case, C is smaller than A. Yeah, that's right, and that's right. Actually, in this case, we do know all of it. C is smaller than A, smaller than B. C is smaller than A, is smaller than B. Okay. That looks like ACC or something like that. Never mind. Yeah, so A is smaller than C and A is smaller than B. We know that A is the smallest in this case. Over here. Oops, over here. But we don't know if B or C is the larger one. To know that, let's first get C back. So add back A. Then we know that we have the same number that we started with. And since we know that C isn't the smallest, we know that we have to store it. So let's copy it to C. Okay, so now we have it stored. We now have to figure out which is larger from B and C. So if we subtract B, then we have one of those jump if negative again. Oops. Let's see. Yeah, in this case we have C. If we go into the negative, A is smaller than C, so in this case B is smaller than C. B is smaller than C. Actually, that's not enough because we already know that A is smaller than B. So A is smaller than B is smaller than C. Okay, so we know we can get everything out here. And we have another case over here. We still know that A is the smallest. That's smaller than C and smaller, which is smaller than B. And no, we are not handling the same cases several times. We are not handling the same number. So in this case, copy from A, go to the outbox, copy from B, go to the outbox, and copy from C and go to the outbox. In this case, copy from A to the outbox, copy from C to the outbox, and copy from B and go to the outbox. Okay, so we should handle all cases, I think, where A is smaller than B. But what if B is smaller than A? Well, then we have to do basically the same thing. We go to the inbox. Right now we want to know is C the smallest, so we compare it to the smallest of this. Oh, that's the way to think about it. I didn't do that before. Oh, I just realized I have not done any jumps, so let's not worry about that right now. Let's finish this, but then we have a lot of jumps to the start to finish up. Let's go to the inbox. Let's subtract B. And with that, we kind of know if C is the smallest. C, C is the smallest if that is negative. Okay. So in that case, C is smaller than B is smaller than A. Okay. And then we know in this case B is smaller than C. And then we don't know what's happening. Is it just me or is the... Oh, this is more bold, the text on that than it is over here. But I think we have more air that makes it zoom in a little bit. But if B is smaller than C and B is smaller than A, then we know that C is not smallest. We know that B is the smallest. So we know we want to store C. So let's add back B. Let's copy to C. And then let's compare it to A. Subtract A. And a jump if negative. So in this case, C and B. Okay, B is smaller than C. In this case, A is smaller than C. Okay, fair enough. I still don't know what is... Oh, B is smaller than both of those. So B is smaller than A, smaller than C. Okay. And in this case, B is smaller than C is smaller than A. Okay. So we just have to handle... Well, yeah, we have to handle these three cases. And we do that basically by copy from B, the outbox, copy from A, go to the outbox, and copy from C and go to the outbox. In this case, we copy from B, go to the outbox, copy from C, and go to the outbox, and copy from A and go to the outbox. This case, however, is a little bit special because we haven't saved C. So we do have C minus B. So we have to add back B, then go to the outbox, and we copy from B, go to the outbox, and copy from A, and go to the outbox. So this should work with all the sortings. What we want to do more is to make sure that when we have gotten everything to the outbox, we always want to go to the top of the program to run it all over again. So we have that. In this case, we can jump the top gun. Hotbox. Jump to the top. This is an awful program, but it should require very few operations. To be honest, I don't think it's possible to do it in fewer operations because we have done all of our logic manually and not in the program. So few operations, but a really hard to understand program. And let's run it and see what happens. A, store that in A, grab B, we store that, we check them, know that B is smaller than A, in this case. Check that C is the first, is the smallest, B is the second, and A is the largest. And then we start over. 3, 5, that is smaller. Well, actually, yeah. Store it, check it against that. Okay, let's put it in this order. Let's run full speed. Oh yeah, with the same we might be able to get it. That's true. With the same number, we might actually be able to get fewer steps. But we have to do loads of checks for that. Yeah, we used way too many commands. The steps, yes, 73. Ooh, that's really nice. Okay, so we did one of those. Let's not do the command lines, the amount of code right now. Let's do the wall incinerator. What? H is okay. But management is attempting to reduce bandwidth by removing all vowels from every word. Send everything from the inbox to the outbox except for vowels. Okay. So what I think we want to do here is... What do we don't want to do? Do we have this... Do we have the possibility of... Oh yes, we do have the possibility to add from... or do stuff from a set variable. Okay, so what we want to do is set up a counter first. I think we want to set up a counter that starts with 0. Then we take a letter, we store it. No, we check again. Oh. Okay, let's see. Copy from that, and this is 0. Copy to the number 6. Space 6, which is a counter. Copy to the counter, and then we want to grab our first digit, I think. Grab that. We subtract from No, we don't. We don't do this. We do this in 2 steps. One step to get the fewest commands, another to get the fewest lines. So let's grab the inbox. Let's subtract 8. If 0, we jump down. If not 0, we add that. We subtract that. Oh, I haven't thought about... There might be some way of combining these. Let's not worry about that. If 0, we jump down. Not, we add back 1. We subtract 2. Check if it's 0. Actually, this should go to the top. Something like that. So if it's 0, we know it's the same digit. Then we don't want to put it on the out belt. We want to grab the next number. Okay, so subtract 2. We want to add back 2. We want to subtract 3. If it's 0, let's start over. If it's not, let's add back 3. Let's subtract number 4. And if it's 0, let's jump to the top. And if it's not 0, then we know that we have something that isn't a vowel. I just assume that we have all the vowels here. I haven't checked it. Then we want to add back the 4. We want to put it to the outbox and jump to the start. This should be the fewest steps, I think. Can't add with a letter? What would that even mean? Well, if you... I'm sorry. If you can subtract with a letter, you should be able to add with a letter. This doesn't make any sense. But okay. Let's do this instead. Letter. Okay. So what we do, when we grab a new letter, we copy it to the letter space. And then we never add, we copy from letter every time. Copy from letter every time instead of adding. Copy from letter instead of adding. Copying from letter instead of adding. Copying from... Oh. Copying from letter instead of adding. At 0, let's get rid of that. And then we check this out. 2, 3, okay, I think we should have the fewest steps, but not the commands. Yeah, that's like half the steps I was allowed to use. Less than that, actually. So let's go back to that, and let's try the other thing as well. Let's get another one. And actually, this is 0. This is letter, and this is a counter. Okay. So, what we want to do. I don't know the order of doing this, but we want to we want to go to the inbox. Yeah, let's do it like this. We want to go to the inbox, we want to copy to the letter. We want to copy from the 0 and copy to the count. And now we have a loop. Now we want to do a loop. We want to... You know, we have the 0. Let's do that. We want to loop, and then we want to start over. So we have the 0. Actually, we don't want the 0. We want to copy from letter, subtract. No. Subtract. No. Subtract. Oh, why can't I get this to work? Subtract what is in the count. And if it's 0, we jump over here. And just grab the next letter. If it's not 0, we have the count, have this, we want to counter. What does that do actually? Let's have a quick look. Don't know if that picks up the counter as well. Yes, it does. It does pick up the counter. Great. Then I don't have to pick it up manually. So we bump the counter. And then we... Then we want to check if the counter is pointing there. So we want to copy from... Oh, we can't do that. Do it that way. Okay. What I was thinking is that we can copy from the space with the counter, but it seems we can't do that. We can only do that when we do mathematical. Oh, maybe copy from. Oh yes. Okay. So we can copy from them. And if what we get is a 0, it means that we get this spot. So jump 0. We jump to the loop, I think. I think we are getting one thing too much. If it's 0, we jump out, we copy from the letter, put that to the outbox, and we jump to the start. Let's see if this works. I think it should work, but I think it is one row too big. Yeah, let's just do full speed. By the way, this is not correct. The Y in the English alphabet is sometimes a vowel, sometimes a consonant. So, yeah, this is not correct, this program. And I can't do anything about it. Because I don't know if it's a vowel or a consonant. Yes. 13 of your commands, I'm using 14. I'm using a little bit too many steps. That's not a worry. But how can I remove one step from this? I mean, technically we could move the copy from L and outbox to the top, but then we need a jump in the beginning instead of this jump. That wouldn't help, really. And just to be sure, we could do this. We first copy the 0 and then get the letter in place. That doesn't make a difference. Or does it? Actually it does, because then we have the letter over here. That's true. We have the letter over here. If we have the letter, we don't have to copy from it. We can do that here instead. We bump the count. No. We bump the count. We check if it's 0, and then we increase it. But then, if we check if it's 0, it will never be 0. If we move it here, it will be... Ah, damn it. This should work. I want to check that it does. So basically, it's copying the letter before we start our loop. Or if we want to end the loop, we copy the letter afterwards, but this is the problem, copying it afterwards. It does work. But it's still one step too large. Wait. Why do I do the copy from... Oh, yeah. It's not copy from count, it's copy from the number count is pointed to. Okay, just for readability, let's do that. The top doesn't really matter, but for readability, copy from the letter, we subtract the count, or we subtract the vowel. If it is a vowel, we start over. That's easy enough. If it's not a vowel, we bump the count. Oh yeah, we copy from position of the count to see if it's 0. What happens? Oh no, I was thinking, what happens if we never check this? We never copy from that, we never check this. Will it go to 9 and then start over? But it wouldn't, because when you go to the 0, it would go round. When you go to the letter minus the letter would always be 0, so it would be regarded as a vowel, and it wouldn't be good. Do we have inbox, outbox? It's none of those. Copy from, copy to. It's possible we have to do something there. And subtract and bump. Plus bump minus. The jumps. I can't see how we could actually get one command fewer. One, what do they call it? They don't call it command. What do they call it? They call it... Yeah, they call it the command. Okay. So how could we remove a command from here? Okay, this jump is to start over the loop and check the next vowel. This loop is to validate if we have checked all the vowels. This is to start over on the next letter. This one is if we have found a vowel. This one, yeah, that's the next vowel we check. This should definitely be possible, and it should probably be easy to do. Oh, maybe. Yes. Maybe. I have checked what happens if you move the copy from to the end of this loop. That didn't do anything. But what if you do this and this, then you have the count, and then you do the validation of the count in the beginning of the loop. So we have placed our letter. We have gotten count into 0. We check if that 0 does exist. If that is no. Does it do anything? Maybe. Check if this is the 0 to start with, and if it is, we jump out of the loop. But we still have to copy from the letter and leave it to the outbox. Still have to bump, we still have to sub the count. I can't see this doing anything. Oh, of course we have to do that as well. Oops. Is it possible that we don't need to reset the counter? I mean, we could technically reset the counter by bump minus that one and check if it's 0, but that's 2 steps, which is what we already have, so that wouldn't do anything. Actually, it would be one more, because the jump if 0 is not... Wait, what if we set it to -1? And then we bump it first? If we set it to -1, we bump that, we copy from it, check if it's 0. I mean, it should work. Should work. We increase it to 0. We check if the letter or the digit is 0, which is this one. Then we copy and check with the vowel. And if it's a vowel, we jump to this. Oh, wait. There's something I've missed. I missed something. This one jumps to the start. What if this one jumps to the start as well? I'm starting to think that this jumps before this one. Let's see what happens. Then we do that. Then we don't need this jump. But we need one jump to not start with a copy from L and put it to the output. What happens if we do that, by the way? Empty value you can't copy from with an empty tile on the floor. Try writing something to the tile first. Okay. That is definitely fair enough. So we basically, if we do this, we need to jump to the inbox. start with, and we read the letter. Well, we read the letter from the inbox, copy to the letters file, copy from the 0, copy to count. Feels like I could do this one a better way. But I have no idea how. Can we sub the vowel? If it's a vowel, we start over at the inbox. If it's not, we bump the count and check if that's over. Actually, just to check, this won't be used now and this shouldn't work. So if we bump the count and then just start over, what will happen? Don't think it should work. Oh, we are never jumping out of that loop. So basically when we reach this space, we'll see it as a vowel, and if we move this over here, we'll... Okay. Can't sub with mixed operands. Subbing between one letter and one number is invalid. Only nice, respectable pairs of 2 letters or 2 numbers allowed. Okay, so that doesn't work. So what I was gonna say is either when we get to the letter, it will see it as a vowel, and if we move that, it will see this as an empty space, and it can't handle that. But instead it sees it as different types with the O. And we can't check if there are different types either. Does it matter if we copy from count and the sub L? No, that should be the same. To be honest, I'm stumped. I don't know how to proceed with this. Let's try. Maybe there's something with looking at the existing code that makes me not see something. So let's try creating a new program with this. And the first one, by the way, let's have a look. That have very few steps, but have quite a few rows. Not that many, actually. 19 rows. Not that bad. But I mean, if this were not 5 vowels, but 300 values, it would be loads of rows. So yeah, 19 commands instead of 13. Is there anything we can use from this one? I don't know. If we grab from the inbox, if we subtract that, we add that and put it to the outbox, let's see what happens. Subtracted, fine, and I can't add. Yeah, I hate that. So that means we can't subtract. We have to copy it to another space. Whatever space that is. That's the letter space. We can't add it. We have to copy from the letter space. Of course this will fail, because we haven't done everything we need to do. There we go. And even if we loop it, this will of course be wrong. Because we haven't... I've only checked one vowel. So, oh, but let's do that. Let's loop it. So we copy, subtract, and you can't handle exception flows either. That would be one way actually for this code to work. If we just do the sub, and then if we have an exception with the wrong types, then we say, oh, we found the letter and put it to the outbox, but we can't do that. It wouldn't be a good way of doing it, but would be a way. So we copy from L. We copy 2L, subtract 0, we copy from L. We subtract. Let's subtract that 0 instead. And if that is 0, we know that this is a vowel, we don't want it in the outbox. Is that correct? Well, yeah, yes, it is correct. It is correct, but is that what we want to do? Let's have a look at this again. If 0, jump to the top. What I'm thinking is, do we want to do something if it's 0? To always go through the whole loop. But we go, say, place a letter here. Something like that. I don't think so. I don't think we can make the code smaller by doing that. And since it is jump if 0, we have to jump out and then jump back. If it was jump if not 0, that would be another thing. Should we jump if... well, we don't have any jump if positive, so no. The jump if negative doesn't work either. We would need the other option, jump if positive, or we have to pick up both of them again and check, and then jump if negative, and that's like 3 commands more. If it's 0, we throw it away. And then we bump. No, this is not gonna work. Check it, bump that. Oh, that was by luck. Oh! 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 This is among the worst code. Okay. Stop. Let's put it over here instead. Just for test. We know that we will never reach the outbox. We grab it. Check it. What? Oh, and then we jump. Okay. So, that's not what we want to do. We want to do another jump. Over here. Yeah. So we check the first number, or first letter, I mean. And soon we will get to know, not this round, but next round, we will get to know we can't do that. No, yep, can't sub with mixed operands. So, before we do that sub, we need to check that one. And we are picking up the letter over here, so we basically need to check it over here. We have bumped that. So if we copy from that, and if that is 0, we start with inbox. This will still not work. No way. No way at all. Because we are never putting anything in the outbox. We just loop it as it is now. This is annoying me. This should be possible to do. Oh, oh. That's true. Stop. This is not 0. We're all bumping that. We're all bumping that. What does that mean? It means that we have to check if it's 5, but we can't check that. So that means we have to copy from that and copy to there. This is the counter. This is 0. And then we can't sub 0. We have to sub the counter. Can't bump the 0. Have to bump plus the counter. Can't copy from the 0. We have to copy from counter. Now we have 13 steps. Let's see what happens. Oh, I made a boo-boo. I should have started with the 0 and then go for the letter. The way it's set up now. Can't bump plus with a letter. What would that even mean? Where did we try to bump plus with a letter? What? I do not get this one. So we get the inbox, we copy to there, we subtract those. Oh, okay. So this is the wrong C. We want to do that instead. Not the value of, not the spot of the value, but the actual value we want to count as. Fair enough. That was my mistake, definitely. Okay. Yeah, but we never got it to... That's true. We never got it to the outbox. That's the problem we have. Yeah, this is... Today, with this game, is a disappointment, if you ask me. Haven't fully finished anything. We've partially finished 2 levels, but not fully finished any of them. That's 0. So let's start over. But the problem is we are not outputting the consonants onto the belter either. Meaning that this is very flawed. Wait, why do I do this? Copy from? Oh, because I want to see if it's 0 and start over. That is actually fair enough. Except that if it is 0, we want to kind of go to the hotbox with it. After getting the letter, and then the beginning, we don't want to go there, we want to go to the end. And this one wants to go there. This one wants to go afterwards. This one wants to go afterwards. Something like that. Why do we have 2 jumps here? Oh, that jump we can get rid of. So here we have the loop for the wall. And here we have, if we have found the wall, we start over. If we notice that it's not the wall, we go to the output, and then we start everything over. But again, we have 14 commands. Actually, this should work. Let's see if it actually does work. And after we have tried that, let's see what commands we can actually use on the letters. I hate that it's not consistent with what can be used on the letters. You can subtract letters from each other, but can't add them. And when you subtract one letter from another, you get a number, not a letter. Oh! We exactly matched the speed challenge. But yeah, the size challenge, not at all. So let's see. Inbox, outbox, we can do that. We know that copy from and copy to we can do. Let's go inbox, add that letter. Subtract that letter. Bump plus that letter. Jump minus that letter. And the jumps have nothing to do with letters or... Well... Jump if 0. And jump if negative. Maybe we can do that. The jump, the normal jump, no. First thing is... Can't add with letter. Yes, exactly. So that should not work. So let's get rid of that. Oh, and once we have do the subtract, let's go to the inbox for every letter. Just so that we know that we have a letter. Subtract. Yes, that works. letter, bump plus. Don't bump plus with a letter. What would that even mean? No, I don't know. You have strange ideas, so maybe it works. Bump minus should work if you can subtract. Don't bump minus with a letter. What would that even mean? Well, if you can subtract letters, you should be able to bump minus a letter, right? Let's check jump if 0. Okay, so jump if 0 and jump if negative. So let's play again. Box, box. Okay, so jump if 0 and jump if negative will never jump with letters. From what I can reckon, at least. Can we use that in some way? What if? What if? What if? What? Okay. What if instead of checking, instead of bumping and then copy from that spot and jump if 0, what if we instead say that no, we can't subtract this one from, okay, let's see, copy from A, subtract 0. No, I can't sub with mixing operands. Damn it. And we can't subtract itself. Well, we can of course subtract itself. But we can't add. So even if we can subtract itself and check if it's the same as that. Let's try. Copy from L. That means we don't have that over here. We don't have this. Copy from L. Subtract L. Jump if 0 over here, because then we know that it's the same letter. But if it's not the same letter, then we basically need to copy from L again. And then we just increase the size of our program instead of decreasing it. Let's see if it works. It should work. Bad outbox management expected N, but your outbox O. Okay. I have no idea why that happened. Okay, yeah. Now I know why. Because when we copy from L and subtract L, if we're not at the end of the loop, this doesn't work. If we're not at the end of the loop, then it will always be 0, and we say start over. Now it should work again. But it would be very few steps if it would have worked by chance. But it wouldn't have worked for real, just by chance. That's the case. In commands, and we have about the speed challenge. Yeah, something like that. The thing is that I don't like this. I want to complete this before going forward. And and I have no idea how to fix it. Let's see. What big differences are there? This is the same program. It's exactly the same program. These two and these two have switched place, otherwise it's the same program. So for this one, let's get rid of it. Sure want to clear your program. Cannot undo this action. Yes, I want to undo that. This still remains. Yeah, this is annoying. Because I think this should be possible. I want to finish this before going onwards to the end. And I want to fix this as well, but I definitely don't want to do the lines challenge, the commands challenge for this one. Actually, why not? No, I don't want to do that. I want to see how big it is. How many lines of commands, rather, are we allowed to use? We are allowed to use 34 commands. But we used 62. That's not a problem right now, because we only went for the speed challenge. We didn't think about the size challenge. But 34, that's about half of this program. It should be doable. It should definitely be doable. I have an idea on how to do it, but I don't want to do it now. And I have no idea how to solve this. So with that, I'm guessing that I'm done for today. And we'll get back to this and hopefully solve both of those. I will do another try, but then I might get help with this one actually. But that's how it is. Thank you so much for watching, and I'll see you another time.